Mr. Harris here, and welcome to a new video of Unit 9.4. In this video, we're going to talk about the effects of acids on building materials. So some common types of building materials that are common in Hong Kong especially are they're built by using marble, limestone, or sandstone. So one common example of using these type of materials is in Tsim Sha Tsui. So maybe some of you have seen this, the Kowloon Mosque and Islamic Center. It's right next to Kowloon Park. This building is made up of marble. Now, there might be one issue with this, is that maybe these building materials, they're able to be corroded by dilute acids. So, does it actually have anything to do with the building materials? Or why, or do they actually even get corroded in the first place? So for that, we'll need to figure it out by doing an experiment. So in this experiment, we'll see whether acids would have any reactions with the building materials. For this particular experiment, we'll be using hydrochloric acid, dilute hydrochloric acid, on marble, limestone, and sandstone. Now to be more specific, the chemical name or the chemical compound that is present in these materials is called calcium carbonate. Now, in the coming few slides, I'll be talking more about calcium carbonate, but for now, I want you to know the name at least. So first off, you grab a test tube and you add lime water to the test tube. Now, I know you guys are thinking, you've heard of this name before, right? So if you remember in chapter 7, I always love to ask you guys, what is lime water used for? What gas does it test for? So if you guys remember, it tests for carbon dioxide, yes. And what is the observation you see? When indeed there is carbon dioxide present, what happens to the lime water? Yes, it turns lime water milky. So it becomes milky. So in this experiment, we'll be seeing whether after the acid reacts with the building materials, we will see whether any carbon dioxide gas is given off. Next, we'll grab another test tube. Okay, we love getting a lot of test tubes. That's what we do. And then we'll be adding marble chips. Now, this is not the chips you're thinking about. Unfortunately, these are not potato chips. So if we do indeed do this in the lab, you're not able to eat it. I'm really sorry. But as I told you, marble is the building material. It is calcium carbonate. So we'll leave it for the experiment. So you get another test tube. You add the marble chips inside. Afterwards, you would add the acid. All right, and then you'll do this. You get the first test tube, which had the lime water, and then you'll combine it. You connect it to the other test tube, which has the acid and the marble chips. And then you'll use a delivery tube to connect them. Now, what's the delivery tube for? When any gas is given off, in this case carbon dioxide gas, it will pass through the delivery tube to the other side, to the other test tube. All right? But we need to make sure that the delivery tube goes all the way inside the lime water. We do not want any gap, so make sure it's going inside. Afterwards, our job is to see whether there is any change in lime water. If there is a change in lime water, then that's how we will know carbon dioxide gas is produced. We'll also see whether there's any changes in the marble chips. As you recall, marble chips, they were the reactants, so meaning they were used in the beginning of the reaction. And then we'll be repeating the same steps with limestone and sandstone, the other building materials. All right, so let's have a look at the results. So first off, we used the marble chips, right? So were there any gas bubbles given off? Yes, there were. And was there any carbon dioxide gas produced? If there are gas bubbles produced, that means obviously it is carbon dioxide. So yes. What is the change in the lime water, if any? I've told you lime water turns milky in the presence of carbon dioxide. And one more very interesting thing is, let me use the other color. The marble chips, they would become smaller after the reaction. So this is very similar to what we've learned in the previous video when we talked about metals, because they're in the beginning of the reaction, they are the reactants. After the reaction, the change is the size would become smaller. All right, so the chips in this case would become smaller. Same thing for limestone, because it is also a building material. When it comes into contact with an acid, gas bubbles are given off. And in this case, the gas bubbles are carbon dioxide. It turns lime water milky, and also the limestone becomes smaller. For sandstone, also the same. Gas bubbles are given off. Okay, one more thing. What if I don't know the gas bubbles are carbon dioxide? Then what? How can I be so sure that it's indeed carbon dioxide? So what I would do is let's rub this part out. Let's not see this part. From the second column, I would know that the lime water would turn milky, right? I'm certain for this because I could see it, right? Now, what type of gas would turn lime water milky? The only possible conclusion is carbon dioxide. All right? So this is a technique or a hint to tell you that indeed carbon dioxide is given off, and for that you can verify or confirm it from the lime water. What is the change in the building material? It becomes smaller as well. The sandstone would become smaller. All right, so let's conclude. Dilute hydrochloric acid reacts with some building materials such as, so what were the examples given? Marble chips, let's say marble only. What else? Limestone and sandstone. During the reaction, what gas is produced? Yes, carbon dioxide. And the building materials, they become smaller. All right, let's move on. So just now, I've told you that marble, limestone, and sandstone, they contain calcium carbonate. So to be more specific, instead of calling them marble, limestone, and sandstone, I'll be using, we're all science students, I'll be using the chemical name, calcium carbonate. So calcium carbonate, when we added that to an acid, it would start to become corroded. Now, one of the reasons is, of course, it produces carbon dioxide. And have a look at the statue over here on the right. You'll see that the face is totally messed up. All right, even the hands, everything is messed up. And one of the reasons is because of the acid. Now, maybe some of you have heard of acid rain. Maybe in your primary school or in Form 1. Now, another reason could be due to acid rain. So what exactly happens when calcium carbonate or any other carbonates are added to an acid? To be more specific, just now I've taught you that carbon dioxide gas is produced. However, to be more specific, as I said, in fact, a salt and water is also produced in the reaction. So let's have a look at your favorite word equations. So on the left, I have calcium carbonate plus an acid. When I react these two together, I would get salt, and I would get water and carbon dioxide. So let's see some examples. So first off, on the left, I have calcium carbonate. I add it into hydrochloric acid. The salt I get is calcium chloride plus water and carbon dioxide. So do you guys recall how I could name the salts? So same technique we've learned in neutralization, same technique we've learned in the previous video when we added metal to an acid. So the first name of the salt would come from the first name of the carbonate. In the case of neutralization, it was the alkali. In the case of metal and acid, it was the metal. And in today's video, when we react acids with carbonates, the first name would come from the carbonate. You would notice by now, always the second name would come from the first name of the acid, sorry. So calcium would come from calcium carbonate. The chloride comes from hydrochloric acid. And of course, don't forget about the water and carbon dioxide being formed as well. So let's see another example. Over here, I have magnesium carbonate. So magnesium carbonate is actually another type of carbonate. So different functions, different uses. So let me give you one more use of calcium carbonate actually. So calcium carbonate is something that you guys, I see a lot of you playing with it sometimes. Another use is a chalk. So a chalk that we use for the blackboard. So for this, let's have a look at this. Magnesium carbonate, when you add it to sulfuric acid, you get magnesium sulfate plus water plus carbon dioxide. So let's see how we could name the salt. The magnesium comes from the magnesium of the carbonate. And where's the pink? The sulfate comes from the sulfuric acid. All right, that is how you name the salt. And again, don't forget water plus carbon dioxide. Since now we're experts, we're pros of word equations, let me try and make one by myself with you guys. All right, the carbonate, let me think of one. Should I use maybe potassium carbonate? Now let me use sodium carbonate. All right, so I have sodium carbonate. All right, and I'll use an acid. Let me take hydrochloric acid. Now, a lot of you would know that I love using hydrochloric acid a lot because one of the reasons is it's really, we can find it very abundantly in the lab. And what is the salt we'll get? The salt we get is the first name of the carbonate, which is sodium. Sodium. And the other name would come from hydrochloric acid. So is it called sodium chloric? No, it's not. As I've told you, sometimes we need to change the name. So the name of the salt is sodium chloride. And guys, what is sodium chloride? This is the table salt you'll find in your kitchen. And finally, don't forget about these two guys. Don't leave them out from the party. You have water and you have carbon dioxide. Alright, so that is how you make a word equation. So to wrap up, I've told you that dilute acids, they corrode building materials such as marble, limestone, and sandstone. And they contain, as I said, to be more specific, the chemical name is calcium carbonate. I'll talk about acid rains in the next video. I mean, there's not much time left for this one. When dilute acids, they react with calcium carbonate, carbon dioxide is produced, as we have seen in the experiment, as well as salt and water. All right, the word equation. Don't forget about that. The word equation. All right, so that's the end of this video. I'll see you in the next one when we'll talk about acid rain. All right, bye for now.